Next topic is hmm, power factor improvement. Okay, what is basically power factor improvement? I'm giving you one example. Like, suppose this is your own factory. Okay, and in this your factory, you are using an induction load. Basically, you are using any motor. So, by using this motor, your factory power factor reduces to zero point 0.6. Suppose power factor in this case is zero point 0.6. Why? Because if you'll use inductive component, then that will decrease the amount of power factor. Clear? Now if your power factor is zero point 0.6, but ideally your power factor should be equal to 1. So you want to improve the power factor. Why? Because every month otherwise you have to pay penalty to the government. Like, suppose if your power factor is so less, zero point 0.6, then every month you have to pay 1 lakh rupees to the government. Okay. But if you will improve the power factor to suppose zero point 0.9, that is approximately near to 1, so your penalty amount would decrease. Maybe it would be 10,000. Okay. And again you will increase from zero point 0.9 to 1, then your penalty amount will be decreased to 0. Okay. So what you have decided that instead of paying every month penalty to the government, you added one more device in your factory only. That with the induction motor, you added one more device. That device name is synchronous condenser. Okay, or we can say synchronous capacitor. So by adding this synchronous condenser and synchronous capacitor, your power factor improves from zero point 0.6 to 1, suppose, or zero point 0.9 maximum. So what you will do? Paying penalty 1 lakh rupees monthly to government, or investing uh, the your money on synchronous condenser so that you will never going to pay the penalty. Tell me which option you will choose. The second one. Okay. So now this is known as power factor improvement. That how you did improve the power factor by adding a simple device that is known as synchronous condenser, or we can say capacitor. So in questions generally they'll ask you that without compensation, like this was the condition of without compensation. Okay, and this is the condition of with compensation. So now in your factory you should know now that if my power factor was zero point 0.6 and I want to improve up to zero point 0.9, how much value of capacitor must be added, right? You must know now. So draw both power triangle, one for without capacitor, one with capacitor. For both the cases, always active power will remain same. Active power means, as I told you, like suppose fan is there in your factory, so it will consumes the same active power with or without capacitor. Yes or no? Because active power is the power which is consumed by the resistive load. So in both the cases, power is same, active power will be same. In this case, cos phi is suppose zero point 0.6. In this case, suppose cos phi is zero point 0.9. So if we know P, if we know cos phi, can we get S for both the cases? Can we get Q for both the cases? So what we'll need to do? That Q new would be equal to Q2 minus Q1. Means both the reactive power would be subtracted with each other. Okay. So Q new would be equal to V square by Xe. See how this formula come? As you know, power is equal to Vi, or we can say power is equal to I square R, or we can say power is equal to V square by R, right? These are the three different formulas for the active power, like the power which we have studied. So similarly, Q would be equal to V square. Instead of resistance, we'll take the capacitor resistance, that is Xc. We know already Q, voltage must be given, and we can get Xc. If we'll have Xc, then we'll get C as well. right or not? So this is a question which will come uh, in your paper.